Because you have to say, like, where are the aliens? You know, it's like the Fermi paradox. Where are the aliens? If the universe is 13.8 billion years old, shouldn't they be everywhere by now? And
CEO Elon Musk revealed something truly terrifying. The mysterious space object known as Oumuamua will make a direct impact in 32 hours. But where did this thing come from? What will happen if this massive object, moving at incredible speed, collides with Earth? And how can we stop it? But most importantly, can we survive it? But to understand the whole picture, we need to understand what this object really is. In late 2017, astronomers made a startling discovery. An object from outside our solar system was passing through at an astonishing speed, named Oumuamua. This mysterious visitor sparked intrigue and debate among scientists and space enthusiasts alike. Why is it called Oumuamua? It derives its name from the Hawaiian language, meaning scout or messenger from afar visiting first. This choice of name reflects its nature as an interstellar traveler and heralded its status as the first confirmed object from outside the solar system to enter our astronomical vicinity. But what exactly is Oumuamua, and why is it so significant? Oumuamua's origins still remain a mystery. Its elongated cigar-shaped appearance and unusual behavior set it apart from typical celestial bodies. The object is estimated to be several hundred meters long, but only about 40 meters wide, making it much more elongated than any asteroid or comet observed within our solar system. This peculiar shape led to numerous theories about its composition, from a solid metal monolith to a loosely held together rubble pile. Another one of its baffling characteristics was its acceleration. As it moved away from the sun, the object exhibited a slight deviation from its expected trajectory, which couldn't be accounted for by gravitational forces alone. While some proposed natural explanations, such as outgassing or solar radiation pressure, others speculated about more exotic possibilities, including the idea that it could be a thin solar sail-like probe sent out by an advanced extraterrestrial civilization to gather more information about Oumuamua. Astronomers worldwide turned their telescopes and instruments towards this celestial object during its visit. Unfortunately, our ability to observe it in detail was limited by its rapid speed and the relatively short time it spent within our observable region. Nonetheless, data collected during its passage provided valuable insights into its characteristics. So, what data have we gathered? Its reddish color, detected through spectroscopic analysis, suggested the presence of metal-rich minerals on its surface. This observation hinted at a potentially rocky or metallic composition, but its exact nature remained uncertain. Its tumbling rotation further added to the mystery, as it rotated once every 7.3 hours, causing its brightness to vary dramatically. Is it possible that it's a probe, or even a spacecraft from an advanced alien race? Possible extraterrestrial origins. Oumuamua's peculiar features set it apart from typical celestial objects. Its elongated shape and rapid rotation suggest that it's not a regular asteroid. Its brightness also fluctuated significantly as it journeyed through space, indicating that it has a non-uniform surface. These anomalies raised eyebrows within the scientific community, prompting some to consider alternative explanations for its existence. Perhaps one of the most compelling arguments for Oumuamua's extraterrestrial origins is the unexpected acceleration it experienced as it passed through our solar system. This acceleration could not be attributed to gravitational forces alone, leading astronomers to hypothesize that it might be propelled by solar radiation pressure. While this phenomenon is not unheard of, the magnitude of Oumuamua's acceleration was greater than expected, raising questions about its true nature. Another intriguing aspect is its absence of a visible coma or tail, which is typically associated with comets. Comets are known to release gas and dust when they approach the sun, creating a visible tail. Oumuamua, however, remained devoid of any such cometary activity. This departure from the norm fuels the notion that it could be an artificial object designed to withstand the harshness of interstellar travel. However, the most fascinating argument for Oumuamua's extraterrestrial origins lies in its intergalactic trajectory. It arrived from outside our solar system, making it the first known interstellar object to pass through our neighborhood. The likelihood of a natural, randomly occurring intergalactic object entering our solar system at just the right trajectory to be observed is exceedingly low. Some supporters of the extraterrestrial hypothesis propose that Oumuamua could be a probe or spacecraft sent by an advanced alien civilization. And what happens if it's indeed an alien spacecraft? If Oumuamua is indeed of alien origins, it would represent an unprecedented discovery with profound implications for our understanding of the universe. The possibility of an advanced alien civilization capable of intergalactic travel raises questions about the scope of their technology, their motivations, and whether they might be monitoring or exploring other star systems. In the case of Oumuamua, the theory proposes that it was once part of a much larger comet or asteroid within its original star system. Some event, such as a violent collision or gravitational disruption, caused a piece of this larger object to be ejected into interstellar space. This fragment, which later became Oumuamua, traveled through the vast distances of outer space until it entered our solar system. As it passed through our solar system, it exhibited some unusual characteristics, such as non-gravitational acceleration. This acceleration could be attributed to the object's interaction with solar radiation. Even though hydrogen is transparent to visible light, it can interact with higher energy ultraviolet and X-ray radiation. The absorption and re-emission of these high-energy photons could generate a small but consistent thrust, causing the object to accelerate. If Oumuamua were indeed a hydrogen iceberg, it would be a unique and rare object, as such conditions are not commonly encountered. This could explain its distinctive characteristics and why it differs from typical asteroids and comets. But let's assume Oumuamua is not of extraterrestrial origin and it's simply space debris. What would happen if it makes a direct impact on Earth? If Oumuamua were to collide with Earth, it would be a global catastrophic event. Let's explore the potential consequences if such an impact were to occur. Oumuamua's exact composition is still uncertain, but it is likely a dense metallic or rocky object. Also, the speed at which it travels through space is immense, making any potential impact incredibly destructive. Upon entering Earth's atmosphere, Oumuamua would experience extreme friction, causing it to heat up and potentially disintegrate or explode before reaching the surface. If it were to survive this fiery descent, the impact itself would be devastating. Impact energy is a critical factor in assessing the destructive potential of a celestial object like Oumuamua. When it strikes our planet, it quantifies the immense amount of energy released upon impact due to the object's mass and velocity, in other words, kinetic energy. Oumuamua's mass would depend on its composition and size. While its exact mass remains uncertain, it's plausible that it could range from hundreds of tons to thousands of tons, considering its elongated shape and estimated density. Now let's put this into perspective. A typical nuclear bomb's energy is measured in kilotons, equivalent to thousands of tons of TNT. For instance, the bomb dropped on Hiroshima in 1945 released energy equivalent to about 15 kilotons of TNT. The impact of Oumuamua, even if it were a relatively small object, would be measured in megatons or gigatons of TNT equivalent. To provide some context, the largest nuclear bomb ever detonated, the Tsar Bomba by the Soviet Union, released energy equivalent to about 50 megatons of TNT. However, if Oumuamua were a more massive object, or if it were traveling at a higher velocity, the impact energy could potentially reach into the teratons or trillions of tons, or even higher, making it an event of unimaginable destructive power, a global killer. What would be the possible outcomes if such a destructive force were to hit our planet? Well, we could be talking about a global extinction threat. A global extinction threat refers to a catastrophic event that has the potential to cause the extinction of a significant portion of life on Earth, including various species, including humans. Throughout Earth's history, several mass extinction events have occurred due to disastrous events like asteroid impacts. The most famous of these is the Cretaceous-Paleogene extinction event, which wiped out the dinosaurs about 66 million years ago. An impact event involving Oumuamua could trigger a similar mass extinction event. The impact of Oumuamua would result in immediate and long-term environmental damage. The initial impact would cause massive fires, tsunamis if it hits an ocean, and earthquakes, leading to the immediate loss of life and destruction of ecosystems. Additionally, the enormous energy released upon impact would also eject vast amounts of debris and dust into the atmosphere. This debris would block sunlight, leading to a dramatic drop in temperatures worldwide. This nuclear winter effect could persist for months or even years, disrupting global climate patterns and severely impacting agriculture and food production. In this critical epoch, Elon Musk stands as a harbinger, urging us to transcend our differences and fortify our civilization. I am not one of the doomsday people. I actually think we're on a good path. But I want to caution against complacency. So long as we are not complacent and have a high sense of urgency about moving towards a sustainable energy economy, things will be fine. There are three elements to a sustainable energy future: sustainable energy generation, primarily wind and solar, stationary batteries for storage, and electric transport. That would still not be a great outcome for humanity. I think we want to expand the scope and scale of consciousness, both biological and digital. Ultimately become a multi-planet species, an interstellar species. Maybe we meet aliens or visit other star systems. We could find civilizations that lasted millions of years and did incredible things, or we may find civilizations that died out. Earth may become uninhabitable, but if we expand and explore, life will continue. Even with climate change, life on Earth will endure. The spotlight narrows on Elon Musk, a reluctant prophet burdened with foresight, urging us to recognize the signs and fortify our civilization. Basically, the cross-sectional area of humans is small. Humans are not densely packed, so there's plenty of room for more people. The environmental movement got somewhat overzealous, concluding that humanity is a plague on Earth. There are people who believe this, advocating for human extinction. Musk sees the Earth's lifespan and believes we should expand beyond it, becoming an interstellar species.